Hello and welcome, dear friends. I will talk about variables and their types. We'll be discussing what value and reference variables are, what's the difference, and how to use them. Without further ado, let's get started. First of all, let me create a new script, call it delete later, and let me attach the script to the canvas object. It doesn't matter what kind of objects we have in the scene, don't focus on this. The only window I'm going to use often is the console window. Open the script. I have already added some lines. Let's go step by step. Okay, what are variables? You may have already heard this term at school. We often had to find the value of x in simple equations. But it's different in coding. In coding, variables are containers that you can put information in and then access later or maybe even change. As you can see, we wrote a few lines in Visual Studio. The variables usage in C# looks something like this. This expression consists of three parts. The first part is called the type of a variable. The second is the name of a variable. The third part is assigned value or literal. We may display the value of this variable in the console window using our magic method print. And let's check if we made everything correctly by pressing the play button. As you can see, as a result, we got the value of variable x. In our print method, I didn't write the value itself, the number. I wrote x. It means that when we call a variable, we can use the value that it keeps. And if I change the x value to 10, the print method will give us a value of 10. I will even say more, with the value of a variable, we can do whatever we want. But let's talk about it a bit later, because now it's time to deal with another monster of coding. It's called type. Type is the basic characteristic of a variable that describes what kind of data it contains. For example, let's imagine a paper box of certain size and let's put in everything that comes to your mind. Well, I thought about lemons for some reasons. So type is our paper box and lemon is our variable. Of course, the boxes are different, they can be made of plastic, metal, or any other materials. It is the same with the types. There are a lot of types in the C#, some of them may be declared by users, some of them are already built by C# developers. If we talk about basic built-in types, we would mention only 15 or something like that. Here is a table with all the basic types. Most of the built-in types are whole numbers. For example, a byte variable contains any whole number ranging from -128 to 127, such as the number 15. At the same time, a ushort variable may contain a number from 0 to more than 65,000. For example, 1000. If we try to assign a 1000 to sbyte variable, the Visual Studio immediately starts saying that we're wrong. We'll most often use four types of basic built-in variables. These are float, integer, string, and bool variables. So why do we need so many types if we can use one that will be from minus a large number to plus a large number? The answer to this question is very simple. A variable that can store more values will simply occupy more memory. Well, we may continue discussing variables forever. Let's just mention some rules regarding the variables that might be useful for beginners. Some types contain fractional numbers in different ranges and with varying accuracy. The fractional part is separated from the whole parts by a dot. This is important. If you put a comma, the studio will become upset. Please note that a literal for a variable float type should contain the letter F at the end, and the literal for the decimal variable type should have the M letter at the end. Also, the decimal type is not that simple, it's very different from the types of float and double. Some experienced friends probably would become very angry because I dare to compare decimals with other types. But for now, just know that if the accuracy of the calculations is very important, then use the decimal type. As you know, we can display variables' values in the console window, and this is useless until no actions have been taken over the variables. So we can perform different mathematical operations with variables. For example, we can declare two variables and assign their amount to a third variable and display the value of the third variable in the console window. We can also immediately assign to a variable a value of any expression. For example, I want to print the sum of two variables. We can also subtract, divide, and multiply variables. All this already makes our program not only cool but useful as well. Well, maybe you want to know what happens when we divide by 0, and it's going to be like this. This is called an exception. C# offers to be serious and emphasizes that it doesn't like jokes. Also, we have an interesting type that doesn't contain any number. It is called string. String variables contain text data. The syntax for declaring a string variable looks like this. String text must be surrounded by double quotes. It will not work without double quotes. The string type variables cannot be subtracted, divided, or multiplied, but they can be added to each other. When we add one text to another text, these two lines simply stick together. This process is called concatenation. Usually, when we use a variable, it is assumed that a variable's value will be changed, and it can be changed any time after initializing a variable. But sometimes we need values that are not able to be changed. These kinds of variables are called constant variables. For example, pi number. Just put the const keyword in front of the type and that's it. All attempts to change this constant will be stopped by the Visual Studio and will be considered as an error. By the way, the constant pi already exists in the C#. You can get it by typing mathpi. So to resume this part of the video, a variable is a memory area that has a type, name, and value. We can change the value of the variable within the area limited by the type of the variable. The type determines what kind of data a variable can store. Any name can be used as a variable name. There are several rules when working with variables. I will not focus on these rules since they are very simple. I'll just list them. And let's move on to the second part of this video. I have to start with a theory. So if a variable is a memory area, then there are two ways to store data in this memory. There are more of these ways, but we are interested in two of them. So there are two types of variables that differ in the way of storing data in memory. These two groups of variable types are value types and reference types. Variables like integers, floats, doubles, booleans, and characters are all value types. Variables like strings, delegates, and classes are reference types. Value type variables contain some value, while reference type variables contain a memory address where the value is stored. It is not a value, it is a reference to the variable's value. Let's look at a simple example. I have added one method. The method initializes two variables of integer type. These are value type variables. They are typically stored in memory in an area known as the stack. This area stores the values of variables we have initialized. It is 5 for x value, 10 for y value. After the method is executed, the area of the stack is cleared. Let me change the type of the x variable, let it be of object type, and it is of reference type. In this case, the scheme will slightly change. Visual Studio saves only the reference to the variable value in the stack, and the variable x will be stored in memory, also known as the heap. As long as we refer to the variable stored in the heap, the garbage collector allocates space for this variable. Thus, the data stored in the heap usually has a longer life. If a variable is no longer being used, the garbage collector reclaims the memory used. So what is it all about and why it is important to understand? Let's look at another example. The first example shows that when assigning the value of one value type variable to another, a further change in one of the variables doesn't affect the other. If I hit the play button, the console window will show values of the A and B variables. Even if I assign a new value to the variable A, the value of variable B doesn't change. This works for the value type variables, because value type variables refer to an exact value. The reference type variable does not contain value, but a reference to it. Let's have a look at another example. This one will be a bit more complicated. I have declared a new class that has only one member. It is X variable of the integer type. I haven't assigned any value to it. I can do it with value types. This means that its value is equal to 0. In the start function, I have declared two variables, a and b, of first class type. These are reference variables, so I got access to the x variable. I have assigned values to both variables. This time, if I hit the play button, I will get a different result. So why is that? When I say that b is equal to a, I mean that both variables refer to the same memory area. In C# we don't say that they're equal to each other. We say that both variables of reference type have the same reference. Having the same reference, they return the same value stored in the heap. And when we try to change something in that area, then all variables that refer to the same area are also being changed. And it doesn't matter what value of x variable is. The main part of the video is over. If you are still awake, then let's talk about one more type of variables. C# is the strongly typed language. It means you can assign a value of the specified data type. You cannot assign an integer value to the string type directly or vice versa. But there are various types that give C# language more flexibility. One of them is the var type. Var can be used to declare any built-in data type or a user-defined type. Let's take a look at these two lines. I have assigned the integer and string to variables of type var, and I can assign an object to a var variable. A lazy programmer's dreams come true. We have a type whose range is from minus everything to plus everything. However, it is not so simple. var has some restrictions. When you declare a variable of var type, the compiler must do extra work to determine the type. While the cost of this operation may not be significant, it is just an unnecessary burden of the compiler. The variable of var type is a method level variable. It means that you have to initialize the variable inside a method. This line throws an error. var cannot be used for function parameters. This line also is not gonna work. There are other restrictions as well, but the most important thing in our case is that we cannot assign a value of any other type to it. These lines are also not gonna work. If the var variable becomes a string, it will stay a string. If it is an integer, you cannot use float values or assign a text to the var variable. I don't often use the variables of type var, I just don't like it. I like it when the type of a variable is obvious. If it is a string type, I should use the string keywords. If it is an integer, I will use the integer keywords. There are cases it's really better to use var, like creating extension methods. I hope I will be able to dive into this topic in the following videos, so don't forget to subscribe to my channel to encourage me to add more tutorials. Thanks for watching.